Hello, 7th graders. It's Mr. Sarley. Thanks for checking in on your homework tonight. I'm going to jump right into it. So, your homework this week on the front, well, tonight and tomorrow, is going to involve multiplying fractions. We've spent a lot of time adding fractions, and when we're adding fractions, it's really important that we have the same size pieces. So, for example, if this problem for number 1 actually had addition, we wouldn't be able to add it like this. First, you'd have to rewrite this so that both the fractions had the same size pieces so that they were both fourths. But you don't need to do that when we're multiplying. When you're multiplying, it's like the procedure is super easy. You're honestly just multiplying the numerators together and the denominators together. So 1 times 3 would be 3, and 2 times 4 would be 8. I wish I had more time to go over why. I'll just show it for the first problem, and if it makes sense to you, cool. So what 1/2 times 3/4 means is 1/2 of 3/4. So if we have 3/4 over here, and then, so the 3/4 would be what's shaded, and then we want to take half of what's shaded. We would be taking this, this, and this. Right? That's half of the initially 3 pieces that are shaded, but when we do that, when we split it in half, now notice that it's an eighths. 1, 2, 3, 4, 5, 6, 7, 8, and that's our new denominator, and we took 1, 2, 3. So that kind of gets at why multiplication of fractions is we can just multiply the numerator and the denominator. I wish I had more time to go through it, but I can only cover so much. So, all right. 5 times 5 is 25, 6 times 7 is 42, straightforward. 3 times 7 is 21, 4 times 8 is 32, and so on. We can do this when we're multiplying fractions. Really, the only thing that gets a little tricky is sometimes you have to simplify the fraction, or sometimes you could simplify the fraction. So let's go over at least one where we have to simplify it. So when you're trying to simplify a fraction, basically you're seeing if the numerator and the denominator have a common factor. And for 14 and 81, they don't, because I can divide 14 by 2. I can't divide 81 by 2. 2 and 15 doesn't really. 15 and 56, can't find one. But 18, that's an 8. 18 and 30 definitely do. Because I see that they're both even numbers. So to simplify it, I'm going to split both in half, which is going to give me 9 over 15. And I think we could do another common factor, and I see they both have 3 in common. So that would give us 3 over 5, and now that's as simplified as we can get it. So that's an equivalent fraction that equals 18/30. So if you see one of my answer choices has 2 answers, that's because I simplified it. So make sure you're checking to see if they have any common factors. And otherwise, that's it for multiplying fractions. It's just something we need to remember how to do. So hopefully that's not too tricky. All right, so practicing ratio problems on the back. We have my niece again, part 2. She's been training for the next race. After running for 10 seconds, she has gone 50 meters. So that's the rate, or the ratio in this problem. It's 10 seconds to 50 meters, or 50 meters for every 10 seconds. If she continues running at this rate, how long will it take Riley to run 300 meters? So the one that's probably the easiest to understand, because we're just scaling up the ratio, would be a double number line. So we have meters and seconds, and then the starting ratio is 50 meters every 10 seconds. You really need to be careful to make sure you line up the number with the correct unit. And then 10 seconds later would be 20 seconds, and that would be another 50 meters, which would be 100. And then we could just scale up until we make it to 300. When we do, at 300 meters, we see that it's been a minute, or 60 seconds. You could have also used A ratio table, and that probably would have been a little bit faster here. So we have meters and seconds. We know that it's 10 seconds for every 50 meters. And now we want to scale this ratio up to 60 seconds. I notice that I can multiply 10 by 6 to get 60. And so 50 times 6 would be 300. If she continues running at the same rate, how long will it take Riley to run 425 meters? Alright, so let's go back to our double number line. We want to make it up to 425, and it looks like we made it up to 300 meters. So I'm just going to keep this going. So after 70 seconds, that would be 350 meters. After 80 seconds, that would be 400. And after 90 seconds would be 450. Oh man, okay. So we wanted to do 425. I noticed that 400 and 450, 425 would go right in the middle. I know Christian's always asking me these hard midpoint questions. 425 is the midpoint of 400 and 450. It's right in the middle. And then down here, what's exactly between 80 and 90? Well, that would be 85. So that's one way that you could have figured that out. It would take Riley 85 seconds. Using a ratio table, if we started off with 10 seconds and 50 meters, something you probably notice is that 50 doesn't go into 425. So in cases like that, it would make more sense to break the ratio down to a number that is a factor of 425, or a number that would work. So one way to do that would be to divide by 2. And that would give me 25 meters in 5 seconds. And now it seems like 25 is going to go into 425, and I guess one way you could figure it out would be to divide. How many times does 25 go into 425? That's a great division question. So 25 goes into 42 once. We subtract that. 25 goes into 175. Well, that's like $1.75, which is 25, 50, 75, 100, 125, 150, 175. I'm counting with my fingers. That's 17. So yeah, I guess one way to solve this problem would be to multiply this ratio by 17. I know already that that's going to be 425 because that's what we just did. And down here, if you multiply 5 by 17, you should end up with 85. There's so many more ways. The ratios are one of the best things to learn in math because they really show you that in math, there's not just one way to do something, and that's why it's kind of a cool subject. Another way to do it would be to find the unit rate. And the unit rate in this problem, well, I'm going to divide 10 by 10 to get 1, and 50 by 10 to get 5. And now that I have that unit rate, 5 is definitely going to go into 425. And if I wanted to figure out how many times, I could divide, again, 425 divided by 5. And when I do that, surprise, surprise, I get 85. So that's telling me that I need to multiply this by 85. And I need to multiply this by 85. Did I get all the ways? Probably not. And I bet at least, I'm going to say 5 of you realize that you can come up with an equation for this problem as well. For any ratio problem, it's a proportional relationship. You should always look for an equation. Do you guys see one? Do you see a way we can get from the seconds to the meters every single time? Well, 10 times 5 would give me 50. 1 times 5 would give me 5. 85 times 5 would give us 425. So it looks like we're taking the seconds, we're multiplying it by 5, and it's always equaling the meters. So 5s equals the meters. And we could have figured that out because if we put in 85 seconds it's going to multiply to 425. Whew, I got carried away. Sorry. This last problem says, in a new 100-meter dash time, Riley finishes with a time of 12 and 5/10 seconds, or 12.5. If she continues running at the same rate, how long will it take her to run 100 meters? I can tell already that this ratio problem is not going to be too hard because my starting ratio is going to have a 100, and that's going to go into what we want, 800. So our starting ratio is 100 meters and 12.5 seconds. And then if I scale that up one, this is going to be 200 meters. And then you just have to figure out what 12.5 or 12.5 plus 12.5 is. And when you do that, you'd end up with 25. And then you could keep on going up until you made it all the way up to 800. But I kind of like that this second ratio doesn't have a decimal anymore. And now I'm just going to use that. I'm just going to start going up by that one. And another cool thing about ratios is you can go up by any equivalent ratio. So 25 seconds would be 200 meters. 50 seconds would be 400. 75 seconds would be 600. And then 100 seconds would be 800. So the answer to this question is 100 seconds. I'm sure some of you multiplied. I'm sure some of you noticed that there's an equation that you could write here, which I think is S times 8 equals the meters. So hopefully, using one of those strategies, you came up with this answer. All right. So our secret word today is Chewbacca, which is the big hairy dude over there. And if you're bored and want to listen to what Chewbacca sounds like, don't stop this video. Oh, really? I'm sorry. I didn't mean that. Stop it! I'm scared now.